So, good morning, everyone. This is Nandeep from Midas, and today we would be learning a bit about modeling and analysis of, modeling and analysis using the drawings available to us. So, since this is a mass webinar, I have put attendees on mute. Press the button shown by number 2 to raise your hand if you can hear my voice clearly. Okay, so I have enough raised hands. If you have any questions during the webinar, please type those in the box shown by number 3 and I'll try to answer most of them at the end of the session. Also, a document with answer to all the questions asked would be sent sometime later. So now, no matter how big or small a project might be, the GAD of the same would always be available to the design engineer. After all, that would be the reference drawing for the structural designing to be done. Most of the time, this would even be available in editable soft copy format like DXF or DWG, which could be easily converted into DXF by a drafting software. So Midas supports the import from such DXF files in several ways to assist the modeling, as we will see today. So we'll be importing the center line for PSC eye girder bridge. That is, we'll be using a GAD for PSC eye girder bridge. We'll be using the section property calculator to generate the edge girders which are having unsymmetrical slabs at top, and we'll also use section property calculator to calculate the properties of a voided slab, and finally we would be using the tendon profile generator to input tendon profile from AutoCAD DXF into the Midas model. Okay, so this is the GAD that we would be using today. The red line represents the center line of the girders. The blue lines represent the center line of internal diaphragm. The magenta lines are the end diaphragm, and the green line that represents the pier cap line. Okay, so in this over here, this rectangular shape is the pier. This is one girder. On the other side is the second span. There are two spans in total. Then these are your internal diaphragms, and these magenta ones are your end diaphragms. Okay. So moving on, this is the cross-sectional view, the mid-section where the PCI girders are there, and the support section for the T girders. The center to center between girders is 3000 mm, that's 3 meter, and center of the edge girder to edge of the deck is 2500 mm. Okay. This is the edge girder property alone. Like for the center girders, okay, it would be 1500 on either side. But for the edge girder, it is 1500 on one side and 2500 on other side. So this section, the properties we would be getting would be using SPC. And then I will show one for the voided slab like this. So while generating the section earlier using SPC, I had just taken a snapshot. So this is how the meshing would be done for the voided slab, and its property would be calculated when we use the SPC. And this is the tendon profile that we would be generating today. So this is the profile plan for the eye girder, and this is the tendon profile elevation. Okay. So not wasting further time, we'll move on to the live demo. So first of all, we'll be importing the GAD. So we'll create a new file. Import AutoCAD DXF file. So we'll be taking in the center lines. Okay, so now this center line has been imported. Everything looks fine, but let us check. So I'll go to query nodes. I'll just check the distance for the first girder, the length of the first girder, that is. So it's 2280, but the unit is meter. So there can't be a single girder of 23 kilometers length, right? So this means whenever you are importing from AutoCAD, the unit system that you select over here should be the same as that was used in the AutoCAD. So I'll go to import again, AutoCAD DXF, browse, and I'll take the same plan. Okay, but I had changed the unit to mm before. So I do that, I go to center line, import, and okay. Okay, so now again if I'll check, the distance would be the same, right? But it's in mm. Okay, so this is just the import of the center line. Now if you'll notice, the pier cap line as well as all the girder lines, everything is in the same plane. But in reality, pier cap is about 2.25 meters below the top plane. So we'll just move these nodes down by 2.25 meter. So I'll select these nodes. I'll go to nodes and element, translate nodes. I have to move this down in z direction by minus 2250. Okay, so this is done. I'll just change the unit back to meter. Okay, so now what is generated right now is just the geometry. The section properties and everything has not been assigned. So to assign properties, you have to go to properties. We have to define the material and the section. So in Midas, in material, add, these are your different types of design. And if you go to concrete, say, so these are the several codes available. We select IRC, ISRC, and we go for M40. So these are the database grades of concrete. Okay, and apply. So if I click on apply, the M40 grade concrete material is created. Now we'll be defining PSC composite section in this case. So the slab would be considered in longitudinal direction itself, but the slab would be transferring the force in transverse direction too. So that's why we need to have, oh, apologies. So that's why we need to create transverse elements such that the stiffness in transverse direction is as it is, but there is no weight added due to that. So to create such elements, we'll have to create dummy material first. So to do that, slab is again M40 grade only, but as I said, we just need its stiffness. We don't need its weight, that is weight density. So I'll just select code here to none. So now I can edit these values. I'll change the weight density to 0, give it a name as dummy. Okay. Okay, now these are the properties that we just defined, and I'll be importing one more from the final model that has already been created. These two we just defined, so I just need tendon and okay. Okay, so the properties have been taken up. Now for the section, so we'll go to section properties, add. Okay, so Midas has several templates for generating the sections. Under the user value, you could go for different kinds of sections, your solid round, track, and several others. You just have to select any particular. You can enter its value or you can select from the database as the case might be. Sorry. Okay, so I guess for round, they do not have a database. For say I section. Okay, so all the database I sections that are there in AISC, all of those would be covered up over here. Similarly, if say you already have the stiffnesses and everything for a particular section, then you could go to value type and you can directly enter the area or its moment of inertia, its centroid, everything could be entered over here. Similarly, templates are available for SRC sections, then combined sections, say to combined die and others, and the PSC sections, which is most generally used. So in this again, there are different templates for one cell, two cell, N cell, PSC mid, or PSC value section again, so that if you have properties, you could directly enter those. Again, you could generate the tapered sections. For that also templates are available, or you can even do it for a value type section. Then there is this composite section. So today what we'll be using is this composite eye. Okay, so based on this guide diagram, you just have to enter the values over here. Okay, and the section would be generated. But now since I already have a model in which I have generated the sections, plus generating the sections using the template is quite easy, so I won't be wasting time in that. I'll be importing these default sections. So I'll go to import. Okay, and I'll just import up to this 11th section. After those, the sections that have been created using the SPC. So I'll import these. Okay, and in 3D, yeah, so when we imported, we had kept all the properties as one. So one of material and one of section has been assigned to everything. This is now how it actually is. So what we'll be doing is, oh sorry, I forgot to remove this, so I'll just remove it now. Okay, so we'll be assigning the appropriate sections now. So these elements which I'll select will be representing the end diaphragm. So I'll just select these and I'll assign the end diaphragm property to these. Okay, then these are my intermediate diaphragms. And for bottom, I'll just take it as pier cap midsection for now. So now if I view in 3D, this is still legible. The transparent part that you see, this is your slab, and the shaded part over here is your eye girder, and this transverse direction is your diaphragm. The bottom is your pier cap. Okay, so coming back to line view, now as shown in the PPT, the edge girder is having a slab of 2.5 meter at the outside, right? So for that we'll have to create nodes at the edge, and before that we'll just be dividing all the segments where we want to create the dummy beams. So I already have these distances, so I'll just go to nodes and elements, divide unequal distance x. So x over here basically means the local x direction. It is 0.25, 3 at 1, 3 at 0.9875. Okay, again be careful of the units over here. Apply. So the division has been done. For the mid part, we'll make it 78.9875. For the edges, 48.9875, comma 3 at 1. Apply. Okay, so my girders have been divided at appropriate locations. So now I'll be translating, rather copying the nodes which I'll be using to create the dummy beams, rather the dummy slab. Okay, so I'll just translate, copy in y direction by minus 2.5. Apply. Okay, so the nodes have been created. Now I'll be extruding these to form my deck slab. So now these transverse nodes are not actually needed where the diaphragm is already there. The main purpose of the transverse elements is to create transverse rigidity. I'll just save it for now to avoid interruptions. Okay, so where the diaphragm is there, at that location, the transverse connectivity is already fulfilled by the diaphragm. So the dummy slab is not needed there. We'll be creating the dummy slab for the locations where the diaphragm is not there. Okay, so I'll select the nodes accordingly and I'll extrude them. The material property is dummy, their section property is dummy1, unequal distance in y direction. So first is 2.5, then 4 times at 3 meter distance, and then again at 2.5 meter distance. Okay, so my tech slab is ready as well. Now towards the exterior there is no diaphragm, so we'll have to extrude these nodes to account for that transfer of force. And there is a common extrusion distance for these, so I'll just enter that 2.5 and rest all will remain same. So this is the view. Okay, but now if you notice the section properties that we have assigned right now, right? Your slab in the longitudinal direction, its stiffness is considered unto this point only, right? If I am doing it in, if I am just deactivating the dummy for now, okay, I'll just inactivate it. So my slab should actually be unto this node, but it is ending somewhere over here, right? So these edge sections will have to be replaced by the edge girder sections. So to do that, we have to import from the SPC. So I'll just go to SPC now, tools and section property calculator. So over here, again, the units that you select, you have to be careful in that. The units have to be same as that of AutoCAD DXF. So force unit doesn't matter, but since I'll be entering the material properties this time, I am changing it to Newton. Length unit is mm. File, import, AutoCAD DXF. Click on 3 dots, browse to the location, mid sections, open. Okay. Okay, yeah, you need to check it. It will auto check if there is any intersection or anything. Okay, so this is created. Now we'll be creating the composite sections. So click on generate composite. Achha, first of all, we'll have to give the base material. So you'll go to model, material, and click on add. Now in this case, I'm taking the material for girder and the slab as same. So I'll just enter the properties. Okay, and I'll click on apply. Once I do that, my girder material has been created. Just change the name to slab and okay. Okay, so two properties have been created. Now I'll click on generate composite. My base material as girder. I'll give name ls for the left section. Oh, apologies. You'll have to change the number of parts to 2 because it only has slab and a girder. So apply. Okay, and one rs for the right section. Apply. Okay, so now we'll be adding the parts to this composite. So for ls, oh, the 3 parts have showed up. I'll just start up in new file. So be careful when you are creating the composite section parts. The girder property. And the slab. Okay, now the composite sections. Be careful. 2 for RS and similarly for LS. Okay, so now we'll be adding parts to composite. So for LS, now there are 2 parts. So part 1, first of all, we'll keep it as girder. We'll select the lines for the girder part. Set the color as light blue, say. Apply. Now I'll just change this to RS and select the girder part for the right section. Apply. Then I'll be giving the slab part. So I'll change this to LS. Part ID is 2. Name is slab, material would be slab, and apply. Similarly for the right section, RS, part ID 2, slab, material is slab, and apply. Okay, so the two sections have now been created. So now I have to calculate properties of this section. So I go to property, calculate composite property. I have to give a mesh size. Say I'm giving it as 25 mm and apply. Okay, so as you can notice at the bottom, the properties will now be calculated and it will be shown in the process message. Usually whenever any error will also pop up, it will be shown. Okay, so it is saying that if these are apart, then the properties would be calculated incorrectly. So you'll have to check that part, that the drawings are accurate and the properties are calculated. So similarly, I'll be calculating it for the right side. That it's written over here, only one composite to be selected by selecting any part of it. So I'll click on that and click apply. So now the properties for RS would be created. RS would be calculated. Again, this kind of message will show up. Okay, so the properties for both my sections have been calculated. Now I'll be exporting composite. So first of all, the left section, let's give it a name, say LS. So I'll click on one. Again, it's written select one composite by clicking any part of it. So say apply. Similarly, for the right side, I'll create a file, RS, apply. Okay. So my left and right section files have been created. Now I can exit the SPC. If further editing or future it's needed, then you could save the SPC file. Otherwise, you can just get rid of it. It's not needed. Okay. So now I'll be importing the sections that I have just created. So to do that, I have to go to properties, section properties. Okay, now it's a composite section. So I'll go to add composite and the composite general section. Okay, so here import SCC files, just click on it. LS is there, open it. That will show just okay. Okay, so the section that we created is now available over here. We'll just change its offset to say from left top. I am giving it a horizontal offset of 1.5 meter. User references extreme fiber, that is the left top location. I said display offset point. Okay, so it is coming over here, so that's not right. So I have to give this as 2.5 meter display offset point. So now it is at the center top of the girder location. Okay, and okay, I'll just give it a name, say left. Okay, and okay. Okay, so this section is created. Now I'll just assign it at one location. Apologies, I'll just activate the girders. That way we can avoid confusion. Okay, so now just my girders have been activated. And I replace it by say left. Okay, so now my slab is extending further up to my last node. Just activate all up to this location. While over here, sorry. Okay, while over here, the slab is not extending. The earlier section that was being shown, that was your dummy section. As for composite sections that you import using SPC, the slab won't be transparent for those. It would be of the same shaded color as that of the girder. Okay, so this process was done for the left end of the girder. Okay, similarly, the same thing has to be done at the right and for the support sections. So right now what I'll do is I'll just show you the final model. Okay, so this is the final model that is generated. Now in this, I'll just show you the other section properties that we imported. Okay, so mid left and mid right, these are the properties for the mid section, the kind that we just imported. Okay, similarly for support sections. Okay, now for support sections, I'll show one interesting thing in SPC again. So I'll go to SPC and I'll just open that SPC file. I have kept the SPC files. say support section SPC file. Okay, so support section is basically a T section. There need not be nodes at these locations, right? But these nodes are kept because our particular bridge over here has tapered section. So if I want to taper from a T to a I section, that is not possible in the software because the number of nodes for a T section are not going to be the same as that of a I section. So to make the number of nodes same, two additional nodes have been generated on each face for the T section. Okay, and then the tapering and everything happens just fine. Again, to create these tapered sections, you have to go to properties, section properties, add tapered, and in this there is a composite general option, right? Composite general section. So you have to just import the SEC files. Say ls I am taking, and at j and I am taking rs. Okay, so once you import these two files, accordingly their sections are shown. Okay, you can tape it from ls to rs, but the point is the sections would be shown, the support section, your mid section, and you just have to specify the offset. But in this case, say if you are choosing left top as the offset location and you're giving your user offset, so for most of the tapered section what you have to give is just at I location. But for composite general section, you have to enter this at I as well as the j end, because if the values are not matching, it would be a a rhombus kind of thing. A inclined section would be created for the straight line, so that would be wrong. Okay, so be careful at this. I'll just show you how it is done in the tapered section over here. Just go to modify. So for tapered section, the properties for the section are taken twice and everything, so it would be a bit slow. Okay, see. So here I have taken right top as the offset and I have entered 1.5 as the distance for I end as well as the j end. Okay, so be careful when you are creating these sections. So that's about it for importing the composite section from SPC. Now I'll just show one demo wider slab section that would be taken. So for now I'm assigning here as a PR section. Okay, if I'm taking a voided slab, so again like before, I have to go to tools, sectional property calculator. Okay, the units again have to be kept same. So in this particular DXF file, the units were meters. So I'm changing it to meter. Okay, mandate the angle step over here is 10 degrees. Okay, I'll just open a DXF file. Oh, sorry. File import AutoCAD DXF. Okay, importing void. This file import AutoCAD DXF, browse, void, open. Okay, and okay. Okay, so now this DXF file has been imported, wherein the internal voids are created using a circle, and as you could notice, it's quite smoother profile. However, let's try one more thing. I'm just going for a new file, not saving this one. I'm units again meter. I'm changing this angle step to say 30. Okay, and I'm importing the same file again, AutoCAD DXF. Okay, so now notice, since I increased that angle step, the way the curves have been taken in the SPC file, it doesn't look like a smooth curve anymore, right? So this is how you can decide. The smoother the curve, obviously, the more time it will take for calculating the section properties. However, the accurate it will be. Okay, so we'll be doing it in that way. I'll just import that. Okay, so I have imported this DXF file. Now for simple section, which is not composite, it's quite easy. You just have to click on generate. It's a plain section. Plain section means basically, say for a web, if you have already drawn the AutoCAD file with its thickness, then you have to select it as a plain section. Or if your AutoCAD drawing is just a line, say for a T section, it is just a horizontal line and a vertical line, then you have to keep it as a line and you have to specify its thickness later. But in our case, it will be a plane section. So I'll go to plane. And usually at the time of, defining the section itself, let us say SEC, usually at the time of defining the section itself, we check this calculate properties now and get it done. However, at times there are certain issues. I'll just show if I click on apply right now. Okay, so it is trying to calculate. And see, this kind of error will pop up at times that very poor mesh is generated and mesh level is unsuitable. So change the mesh density. Okay, so when this error pops up, you can just close this. Now your section has been created. You can just recalculate its property. So you go to property, calculate section property. You just make your mesh as very fine. You click on it and click apply. Okay, so now the finer mesh is generated and notice the properties of the section have been calculated. So once this is done, you could export your section. Just double click on export over here in tree menu and generate a Midas section file. Go to browse, give it some name, say deck, save, click on the section that is generated and click apply. Okay, so now the section file has the properties for this particular voided deck. So you can exit this. No, I don't want to save the changes to SPC. Okay, I guess we assigned the wrong property. Yeah, I'll just change this one to peer. Okay, and now I'll just select this particular section to show how a new section imported could be assigned to this. So we'll go to properties, section properties, add, and I'll just create a new section. So this one that we imported, it's a value section. Sorry, PSC, say PSC value, import from SPC. Okay, so it's a deck. So accordingly, its property would be taken up. You can enter certain values over here. These are for design. Then if you only want to check shear at certain locations. Okay, it's 2 meter section, so 1.5. Say, okay, 1.2.4. Okay, you can give rest as auto. Specify torsional thickness 1 and okay. Okay. So you'll have to do it in this way if it's a PSC section. However, if it's a general section, you go to add value, you go to general section, and again import from SCC option is available. You can import your deck section. All the properties would be as it is, and just give it a name, and you are done. So if you noticed in PSC value, you had to enter certain values. So those would be used for design. If you are not performing the design, you could enter arbitrary values. For analysis, the properties would be calculated using SPC and those would be used. Okay, for general section, no such thing is needed. So now we have created this 1, 2, 3 general section. Okay, and I can just drag and drop over here and just notice this deck with the voids is created. Okay, then analysis further could be performed on this and you could check the results. So I'll just activate everything again, and now we'll go for the tendon properties. So I'll just save this model separately. So I'm just making it into a model and save. Okay, so now for this model, I'll just open it. Okay, so the tendon profiles have already been given. I'll just remove these. Okay, and the tendon property has been defined. So you know how to go to that part. You can go to loads, temperature pre-stress, and tendon property. So this is the one that is already defined. It's an internal tendon The material was tendon that we defined before. It's tendon area. You don't need to enter this value. You can just select the strand diameter. You can enter the number of strands and the area will come. The duct diameter you need to input, and rest of the default values would be there. You could change these to suit your purpose. Okay, so you have to define a tendon property. Now we'll be importing the tendon from the DXF. So to do that, you go to Tools and Tendon Profile Generator. Okay, so click on that and this kind of window will pop up. So we'll just browse to the DXF file which has our tendon. So go to tendon and open. Okay, so it has these layers. I'll just import the tendon layer. Okay, so these are my tendons. Okay, so it's a single tendon. Basically, one is your plan view, another is your elevation view. Okay, so tendon I'm giving name say G1. Property is tendon as we define. Assigned elements. Now, this is basically a half girder diagram, right? Usually those are made available if you are into proof checking. So if I go to the plan view over here, if I check the element numbers, so until my half girder, it is from element number 54 to element number 66. So in this case, the element numbers are, in sequence. Say if they are not in sequence, you could go to nodes and elements, renumber elements, and you could just select all nodes and elements and renumber them accordingly. So it will be in sequence. Okay. So that has already been done. For our purpose, it is from 54 to 66. So I'll just write it over here, elements number 54 to 66. Okay. Reference axis is element. Now the XZ plane, that is the elevation. So the origin point I'm taking over here, and XZ plate tendon I'm taking. Okay, so if I click over here, only one part is becoming red. That means only that line segment has been selected. Whereas we need the entire, all the segments until the half length. So we can create a box like this and all the segments would be selected. Okay, so see there are total 14 segments. Now for the XY plane, origin point is this location. Okay, so that's the yellow one. And my XY plane tendon is this. Okay, so everything became yellow. It's just a single tendon. My insertion point is end I of element number 54. That is the beginning. Okay, the offsets that I am giving is Y direction. There is no offset in plan, as you saw, it's at the center. In Z, it is minus 1.5 meter. And I click on add. Okay, so this has been generated. Now I'll click OK. So a text file is created. It's not a big text file, it's a small file. So you just select the contents of this file, copy it, you go to tools, mct command shell, just paste the content over here and click on run. Okay, so once you run it, a message will pop up over here in the command message that there are 0 errors, 0 warnings. If there are errors and warnings, you have to deal with it accordingly based on the message. Otherwise, since there are no errors, that means your half tendon should have been generated. So yes, there's a tendon profile, and if I go to display, I'll just disable the element numbers. So my half tendon has been generated, right? But we are not interested in half tendon. What we are interested in is the full tendon. So I'll just activate the first girder for now. Okay, so to generate the remaining half, we'll just edit the properties over here first of all. I just activate the element numbers. So my first girder is from element number 54 to element number 79. So I'll change this to 79, and the total girder length is 22.8 meters. But the values entered are up to 11.4 meter only. So from my last point, I'll just make it symmetric. Okay, so now the values in XY and XZ plane have been entered up to 22.8 meters. Okay, so I do this much and I say okay. So now if I display the tendon, it is coming for my entire girder length. Okay, so similarly, if I'll just activate all, disable the node numbers, I can copy this tendon profile to other girders. I have to go to loads, temperature pre-stress, tendon profile. I'll just select this and I'll click on copy. I'll select new assigned elements. So I'll just move it to the second girder, say. So my new assigned elements are from this location to this location. Okay, 156 to 81. Insertion point is 156. Insertion element, and I click on add. Okay, so it has been added for the second girder. Similarly, for the third girder, I can select from this element to this element. Okay, and notice here it is element number 1, then 258 to 283. So you can guess that something is wrong because we have renumbered, so it should be in sequence. So what has happened here is that peer has been selected. So you can simply remove this one. You can say element insertion point is 258, add, and okay, close. Okay, so now total 3 profiles have been created for 3 girders. Similarly, profiles could be created for other girders. Okay, now we have defined the composite sections using SPC as well as simply, but these sections, for them to be used as composite, you'll have to give composite section for construction stage. That is not in the scope of this webinar, but I'll just show you what will happen if you do not do that. So I'll just go to 3D view. I have assigned the construction stages and everything in this as needed. Okay, I'll just disable the nodes for now so that it's a bit better view. Okay, so this is my first construction stage. My pier and my pier cap is coming. The second construction stage, notice now these are my composite girders. Okay, so the slab is not showing up right now, because for these I have assigned the composite section for construction stage. But if I do not do that, that is I haven't done it for the second span, and if I go to the next construction stage, notice the transparent part is activated as soon as the girder is activated. Transparent part means the slab, not in the transverse direction but in longitudinal direction. So this is basically wrong. Until your slab is cast, only your girder should be there and only its properties should be considered, right? So since I have done it for my first span, now when I go to CS4, okay, my dummy members as well as my slab for the girders are activated. I'll just deactivate the dummy members. See, so now my slab for the first span is activated along with the dummy members. Okay, so that's how it should be. What's happening for the second span is not correct. Okay, so whenever you are giving a composite section, do not forget to go for the composite section for construction stage. Okay, so that's it for today's webinar. Thank you for joining us. If you have any further questions or requests, you could send those to us at techsupport@midasIT.com and we'll get back to you. Okay, so thank you very much.